and all. Myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the today's lecture, we are going to learn about some of the problems involved in the Ampere circuit law in electromagnetic waves and transmission lines. And these are the problems under magnetostatic fields as well as the time varying fields in MTL. So before going to solve some problems based upon this Ampere circuit law, so first, what do you mean by Ampere circuit law? That is given by closed line integral L H dot dl is equal to I enclosed. Means the closed line integral around a magnetic field intensity with a differential component L is to be given as the net current enclosed by that path, and it is given by integral S J dot ds. So in this particular lecture, we will solve some problems based upon the current density and the magnetic field intensity, followed by some magnetic vector potentials. The terms which are involved in the Ampere circuit law, based upon that, some of the problems are going to solve in this particular session. Okay, so this is what actually the Ampere circuit law. Closed line integral L H dot dl is equal to I enclosed equal to integral S J dot ds. Now, given the magnetic field vector potential, A is given as A equal to rho square by 4 into Az Weber per meter. So that magnetic vector potential is generally measured in Weber per meter, which is similar to that of electric potential. That is, electric potential is represented with V and it is measured in volts. Whereas magnetic vector potential can be given by here with the notation as A, and it is to be measured in terms of Weber per meter. Now calculate the total magnetic flux crossing the surface. Phi is equal to pi by 2, and the radius is ranging from 1 to 2 meters, and Z value is given by, means the range of Z is to be given as 0 to 5 meters. Okay, so based upon the given data, first we can consider here the flux which is passing through the surface. In order to calculate the flux, means magnetic flux can be represented with psi, and psi is equal to the formula is given by integral S V dot ds. Right? So to find here, flux is unknown variable. B is the notation for magnetic flux density, and this B is also an unknown one. Right? To find here two unknown variables, first we have to find the magnetic flux density B. So with the help of the given, means A value is given, that is rho square by 4 into Az, and the ranges of the variables are rho and Z is given 0 to 2 meters as rho, and Z is 0 to 5, along with the phi component is given as pi by 2. Okay, so to solve this, first we have to evaluate B value, and the relation between magnetic flux density and the magnetic vector potential A is given as B equal to del cross A bar. Right? So in the equation itself, we'll have a rho phi Z variables are given, and rho phi Z variables are given case. The formula means the type of coordinate system or cylindrical coordinate system. In that, the components are rho phi Z, and the differential components are d rho d phi, and dz. Okay, depending upon the given finite values, we will evaluate first magnetic flux density as B, which is the formula is given by 1 by rho A phi and Az, along with dou by dou rho, dou by dou phi, and dou by dou z. And the third magnitude components are given as vector A is given as magnetic vector potential A is given as A equal to rho square by 4 into Az. Means there is no phi component, there is no rho component. Hence, rho component and phi components are zeros. Z component only given, that to be considered as rho square by 4. So upon expanding this equation, 1 by rho into A rho dot dou by dou phi of rho square by 4, 0, dou by dou z of 0 minus A phi into, minus means rho A phi, here rho A phi into, and this one Dou by dou rho of rho square by 4 means 2 rho by 4. Dou by dou rho of rho square by 4 means 2 rho by 4 minus dou by dou z of 0, 0 plus az into means dou by dou phi of this will be 0. Then dou by dou z of, see, dou by dou rho of 0, dou by dou by of 0, then becomes 0. So, which is equal to 1 by rho. First component is completely 0 and the third component is completely 0. Now coming to this minus rho a phi into 2 rho by 4 is to be obtained. So, this row and this row gets cancelled. Minus 2 gets cancelled. Rho by 2 into a phi is to be obtained as the value of b. Okay, minus rho by 2 into a phi is to be obtained as the value of b. And this b can be measured in terms of Weber per meter square or sometimes Tesla. Okay, Weber per meter square or magnetic flux density can be measured in Weber per meter square or Tesla. Now with the value of this b, we will find the ds formula first. So psi is equal to integral s. Integral s means we are considering with plane and the plane values are to be considered as with rho and z, right? So rho equal to 1 to 2 meters and z is equal to 0 to 5 meters. And what is that value? B is got minus rho by 2 into a phi dot ds. ds means as to, we know the differential components and here and rho z are the components. Then phi direction we have to write. Hence the formula for ds is given by ds is equal to d rho dz into a phi. So in place of ds we just write here d rho d phi d rho dz a phi. Then a phi dot a phi value is 1. Then integral means minus 1 by 2, then d rho dz. a phi dot a phi value is 1, then minus 1 by 2 can be right out of integration, and for 1 it is rho. If you substitute, for rho is there, then rho square by 2 is the integration for that, then limits are 1 to 2, and for z it is z and limits are 0 to 5 can be obtained, which is equal to minus 1 by 4. See, already 1 by 2 is there and it is to be multiplied with 2. Then minus 1 by 4. Then rho square. Again rho square by 2 and 1 values. If you substitute over here, 2 square value as 4 minus 1 square becomes 1 into and z has to be 5. Right? 5 minus 0, it will be equal to 5 itself. Then minus 1 by 4 into 4 minus 1 as 3. 3 into 1 becomes 5. Then which is equal to minus 15 by 4 Webers. Okay, so magnetic flux can be measured in Webers and its value is to be given as minus 15 by 4. Right? So this is the way we can calculate with the help of vector magnetic potential how we will evaluate the magnetic flux density. From the flux density, how we are going to find flux crossing that surface. Right? So this is the example formula for the magnetic vector potential. Next, in a certain conducting region, H is to be given and as yz into x square plus y square into ax minus y square xz into ay plus 4x square y square az ampere per meter is given. Then determine J at 5 to 3 and find the current crossing through x equal to minus 1 and y and z are the variables which are ranging from 0 to 2. Right? So to find y and z values, we use here first. Now to find the current density J and the relation between J and H is to be given according to the point form or differential form of the Ampere circuit law, that is del cross H bar is equal to J. So find first del cross H bar, it becomes the value of J. So del cross H means we need to find determinant form Ax bar, Ay bar, Az bar, dou by dou x, dou by dou y and dou by dou z. Then in the x component means yz into x square plus y square. Then minus y square xz is the y component and 4x square y square is the third component, which is equal to, upon expanding this one, ax into dou by dou y of 4x square y square means 8x square y, then minus dou by dou z of minus y square xz means 2y 2xyz dou by dou y of this value 8x square y square, then minus of, so already in the formula itself negative is there, we are this considering negative term, then it will be plus 2xyz. Why? Because x and z are the constants. We are dou by dou y of this will be means 4x square y, and dou by dou z of this means see, dou by dou z of means plus y square x. Why? Because we are differentiating this one with respect to z, hence y and x are the constants. Y square x minus ay into, then dou by dou x of this thing means 8x y square minus dou by dou z of this thing means y into x square plus y square, right? Plus az into, az means dou by dou x of minus y square z, then dou by dou y of this thing means dou by dou y of minus dou by dou y of yz means x square yz plus y cube z is to be left out. Okay, which is equal to ax into 8x square y plus y square x minus ay into 8xy square minus x square y minus y cube. Okay, then plus az into minus y square z minus dou by dou y of 8xyz means minus x square z, then minus y cube means 3y square z, right? So this is the way the del cross h value to be obtained. Now if it is to be expressed in terms of vector form, in order to write here in place of the finite amount of magnitudes, we just substitute over here x by 5, y by 2 and z by minus 3. So wherever the x value is to be obtained, in which places x is to be substituted as 5 and y by 2 and z by minus 3 to get the j value as j is equal to, then need to be obtained as j equal to something into ax plus some finite value into ay, some finite value into az need to be obtained as j. Then find the current passing through x is equal to. So to find current means here current in terms of I and j, integral s j dot ds. So in order to write the ds formula here, dx, dy, dz are the differential components. Now x variable, x is to be considered as the direction, hence ds is equal to dy dz into ax. Right? So from this j, we have to consider only x component, that will be written as here. So integral s means y equal to 0 to 2, z equal to 0 to 2, j component means substitute over here j value as j is equal to 8 into x square means 25 into y as 2 plus y square 4 into this x value is 5. Total into ax is to be obtained for the x. That value means 55, 5 is a 4400 plus 4 5 is a 20. That value means 420 into ax is to be obtained. Or before substituting this xyz values means we have to write the formula in the magnitude equation as 8x square y plus y square x in place of x component. So that can be written as 8x square y plus y square x into ax dot ds by dy dz into ax. Why? Because see here the variables are given as y and z and those are ranging from 0 to 2 means the variables are y and z means direction in which it is to be vary as particular through x. Hence the formula for ds is given by dy, dz and ax. Okay. Now ax dot ax value is 1. Then integration with respect to this thing, then limits are to be substituted over here. Then I is equal to, see, for the first case it is to be 8 x cube by 3, sorry, 8x square, 8x square into y value is to be, means y square by 2, limits are 0 to 2, then plus y square x means y cube by 3, limits are 0 to 2, and x also is there. Then z is to be substituted as z, and z value is to be 0 to 2, and here also z is to be 0 to 2. Then I is equal to 8x square. 8 into x means 525, then into y square by 2. Then if you substitute y square as y value is 2, 2 square becomes 4, 4 by 2 is 2, then z is 2, right? Plus y cube by 3. Y cube means y value is to be substituted over here as 2, then 8 by 3 into x value is to be 5 into z is to be 2, right? So I is equal to, here some finite amount of means 25 into 250, 50 into 2 is 100, 100, 800 plus 5 to the 10, 80 by 3. So upon simplifying this one total thing, 2480 by 3 then is equal to be measured in terms of amperes. Okay. So this is what using the Ampere circuit law, how you are going to find out current density. From that, current calculations are to be performed with the help of point form of Maxwell's equation as Ampere's circuit law. Next, a current distribution gives rise to the vector magnetic potential as A bar is given by x square y ax plus y square x ay minus 4xy az Weber per meter. Then calculate the following: B at minus 1, 2, 5 and the flux through the surface defined by. So a vector magnetic potential is given, we need to find B. So B is equal to the formula as del cross A, and in the form of A, that is ax, ay, az, dou by dou x, dou by dou y and dou by dou z. Ax value is to be x square y, then y square x minus 4xy, right? Which is equal to ax into, then dou by dou y of means minus 4x, dou by dou z of this thing 0, minus ay into dou by dou x of minus 4y minus dou by dou z of 0 plus az into, az means dou by dou x of this thing means y square, dou by dou y of means x square. Okay, then which is equal to minus 4x into ax plus 4y into ay plus y square minus x square into az need to be obtained, right? So first we have to find B at this particular. Hence, substitute x by minus 1, y by 2 and z by 5 in this. Then minus 4 into x value is minus 1 into ax plus 4 into y is 2 into ay plus y square as 4 minus x square as 1 means minus 1 into az, which is equal to 4ax plus 8ay plus 3az are to be obtained the value of magnetic flux density. Generally, this can be measured in Weber per meter square or Tesla. Okay, then this is the value need to be substituted over here. See, if your variables are given in order to find flux through the surface, that formula is given by psi is equal to integral s b dot ds. And for the formula for ds is given by ds is equal to dx dz into dx dz into ay, and this one will be y equal to 1. So dx dz into ay means we are considering this one with respect to y component, hence it will be integral. Then x is equal to 0 to 1, z is equal to -1 to 4. B value to be considered as ds means here in the direction of y. Hence we are supposed to consider direction component as y direction, that is 4y ay dot dx dz ay. Okay, why we have considered only y component, understood I think everyone. Y means here the formula for ds is given by in terms of y, hence we have considered only y component over here, which is equal to then 4 integration 4y, and with respect to x it is x, limits are 0 to 1, z it is -1 to 4, then which is equal to 4 into y value to be considered as 2 into x is 1, then z is 4 minus of minus plus 1, which is equal to 4 2s are 8 and 8 5s are 40. Psi is equal to 40 Webers are to be obtained, right? So magnetic flux can be measured in terms of Webers, so that value is to be obtained over here as 40, right? So this is the way, if the magnetic vector potential is given, from that how to find the magnetic flux density, and with that the flux through that surface, how it is to be defined. Okay, so B equal to del cross A is the fundamental one, and from that psi is equal to integral S B dot ds need to be evaluated. Next, another, if again H is equal to YAX minus XAY ampere per meter on the plane Z is equal to 0. Determine the current density means J we have to find, and verify Ampere's law by taking the circulation of H around the edge of the rectangle Z is equal to 0. Then the range is 0 to 3 and -1 to 4 as the Y values are X and Y. Okay. So first we have to find the J. The formula is to be as del cross H bar is equal to J is called as point form or differential form of the Ampere's circuit law. Then del cross H is equal to del cross H bar is equal to determinant of again AX, AY, AZ, dou by dou X, dou by dou Y and dou by dou Z, and X component as Y, then Y component as minus X, and there is no Z component, hence it will be equal to 0. Then upon expanding this equation, Ax into dou by dou F of 0, then dou by dou Z of X will be 0, then minus Ay into, then dou by dou X of this is 0, dou by dou Z of Y becomes 0, plus Az into dou by dou X of minus X means -1, dou by dou Y of Y is 1, okay, which is equal to, means del cross H bar is equal to J equal to is to be obtained as first 0, second 0, third component -2 Az is to be obtained, right? So upon, in order to verify Ampere's circuit law, we need to find here integral I enclosed is equal to integral S J dot ds, where this J value is to be given as J equal to, see, equal to integral X equal to 0 to 3, Y equal to -1 to 4, and J value to be obtained as -2 into Az. -2 into Az. So this is to be Z only, no. Okay. So X equal to 0 to 3, Y equal to -1 to 4, -2 into Az, and ds formula need to be considered as dx dy Az. Okay. So which is equal to -2, then Az dot Az value is to be 1, and if I integrate this one with respect to constant as x, then it will be limits are 0 to 3, then y will be y, limits are -1 to 4, which is equal to -2 into 3 minus 0, then 4 plus 1, which is equal to -2, 6 5 is 30, -30 amperes. Okay, so from this, the circulation of L around a closed path means we have to evaluate this one, closed line integral L H dot dl, which is equal to I enclosed, where the current enclosed by that path is represented with integral S J dot ds. To find this j, first we have to go for del cross h bar is equal to j. With the help of that, we will find the value of j. Then after that, j need to be substituted over here, I enclosed. And finally, we'll be getting the current value need to be as minus 30, and it is to be measured in terms of amperes. Next, a point charge of 10 coulombs moves with a uniform velocity of 2ax minus 4az meters per second, means velocity is given as 2ax minus 4az meters per second in an EM field, electromagnetic field, having E equal to ax minus 3ay plus 8az volts per meter and B equal to 0.3ax plus 0.1 ay Weber per meter square. Velocity is given, electric field intensity E is given, and the magnetic flux density B is also given. Now from this we should find first electric force, then magnetic force, and the total force on the charge. Right? To find this first, Fe, electric force, nothing but generally the electric field intensity is given by force per unit charge. Then from this, electric force Fe is given by electric field intensity is multiplied with the charge is Q. So Fe equal to Q into E bar is given. Now what is the value of Q is given, that is 10 coulombs. 10 into E bar as Ax bar minus 3Ay bar plus 8Az bar, which is equal to 10ax minus 30ay plus 80az and Fe to be measured in terms of newtons. Similarly, in order to find Fm, the formula is Q into U bar cross B bar. Right? So first evaluate U bar cross B bar value equal to Ax, Ay, Az, and so generally different procedures are there. Direct cross product also we are going to consider. This is the one of the easiest way, that's why I'm following. This is the method. Dou by dou x, dou by dou by dou by dou z. Here this one is in the partial normal derivatives case, we just consider directly partial derivative terms. Now we are performing the curl between velocity u and the magnetic flux density b. Hence first write u value as 2 as the x component, y is no y component, hence it is 0, z is minus 4. Similarly for b, x component as 0.3, y is 0.1 and there is no z component. Now find the distance. See here, ax bar into, this will be 0, then plus 4 into means 0.4. 4 into 0.1 is 0.4. Minus ay into, then 2 into 0, 0, minus 4 into 0.3, that becomes 1.2. Plus az into means 2 into 0.1 is 0.2 minus value to be 0. Minus 0 into 0.3 is 0. Hence it is 0.4 ax plus 1.2 ay plus 0.2 az are to be obtained as the value of E bar cross E bar. And that is to be multiplied over with the charge Q, that is 10 into 0.4 ax plus 1.2 ay plus 0.2 az. Okay, which is equal to, so by multiplying this one, the total equation with 10, then it will be 4 ax plus 12 ay plus 2 az is the value of Fm. Right? So this also can be measured in terms of newtons. And to find the total force on the charge, that is F is equal to Fe plus Fm. Or we can go for the formula as Q into E bar. E bar plus U bar cross B bar. Okay. We can go for, this is the one of the formula, or else by adding electric force with magnetic force to get the total force. Then Fe is 10ax, means by adding these two, 10 plus 4, it becomes 14ax, then minus 30 plus 12 means minus 18ay, then 80 plus 2 as 82az. AZ newtons. Right? This is the way we can measure the electric force, magnetic force, and the force due to the electric as well as magnetic fields if the charge and the velocity, electric field intensity, and the magnetic flux density are given case. Okay, next. In a certain material, XM, this is the notation for magnetic susceptibility and it is given by 4.2. And H is to be given as 0.2 x AY ampere per meter. Determine mu R and mu, then magnetization as M and magnetic flux density B, and from that current density J. Okay, so use the means now to find mu R, the formula is 1 plus xm. Relative permittivity in terms of magnetic susceptibility is given by 1 plus xm, 1 plus 4.2 given as 5.2 is the formula for the mu R and Henry per meter. Then mu equal to mu naught into mu R, that will be given as mu naught value as 4 pi into 10 power minus 7 Henry per meter into 5.2 value, right? So by multiplying these two, then it will be 4 2s are 8, 0.45s are 20.8 pi into 10 power minus 7 mu Henry per meter. Okay, so this is the value for mu, and the first value is this, and the second is this. And coming to the third, magnetization M. M can be obtained as, that is mu naught into H plus D equal to epsilon naught into E plus P. Similarly, magnetic flux density B equal to mu naught into H plus M. So this magnetic flux density B bar equal to mu naught into H plus M. From this, H is to be measured as B bar minus mu naught into H. Okay. So to find here, B is also unknown, and we have to find first B, D value, we can use here H. So B equal to, to find B, the formula is mu into H bar, where mu is mu naught mu R into H bar. This value is to be 20.8 pi into 10 power minus 7 is to be obtained as mu, and H is to be as 0.2 into AY, right? So which is equal to 20.8 into 0.2 pi into 10 power minus 7 AY Weber per meter square are to be obtained. Then this value need to be substituted over here, then to find this thing mu naught into H. Okay, so which is equal to B bar as 20.8 into 0.2 pi into 10 power minus 7 AY minus mu into H value to be 20 point mu into H value as same thing, then 20.8 B bar as mu into H. That mu value is to be same, then magnetization getting cancelled, 8 into 0.2 pi into 10 power minus 7, then both gets cancelled, and magnetization need to be a scalar. Then now to find E value as J, that is formula is given by del power cross H bar. As we know that, so AX bar, AY bar, AZ bar, del cross H bar is to be evaluated as dou by dou X, dou by dou Y, and dou by dou Z. Then Hx as 0, Hy as 0.2x, and here X is also there. X is also. Then X and Y component is 0. To find this, Ax into 0 and this 0 minus Ay into 0, then plus Az into dou by dou X of this thing is 0.2, then minus 0. Okay, so upon then del cross H bar is equal to J equal to Ax into total 0, Ay into 0, then it will be 0.2 into Az, and current density ampere per meter square is to be given, right? So this is the way we have solved some of the problems which are involved in the Ampere's circuit law, and from that, how we are going to evaluate the problems which are based upon Ampere's circuit law means using the integral form as closed line integral L H dot dl is equal to I enclosed. To find the current, we can use the current density formula as integral is J dot ds, and if the magnetic vector potential is given, then from that we have to find magnetic scalar potential, and from that field intensity, flux densities are to be evaluated. From the flux densities, we will be finding magnetic flux which is crossing that surfaces, right? And sometimes if the electric force and the velocity, electric field intensity and the magnetic field intensities are given, then for that case, if you find the electric force and the magnetic force and total forces, if you want to find, in order to find electric force, we use electric field intensity formula as 1 is E equal to F by Q, and for the magnetic force it is Q into U bar cross B bar. Then to get the total force, we have to add both the forces related to electric fields as well as the magnetic fields. These are the problems which are based upon some of one of the Maxwell's equation, which is to be derived in the case of magnetostatic fields as Ampere's circuit law. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.